not all fish at all times will use this method, the double pump system. Right? Most of them will, most of the time. Well, just think of the last time you just watched a goldfish in a bowl, and it's bloop, bloop, bloop. Okay, that's what it's doing. It's alternating positive and negative pressures in order to draw water in through the mouth and out the opercular valve. But there is another way in which we can ventilate the gills. Right? There's another way in which we can get unidirectional flow of water over the gills, and that's called ram ventilation. This is true of a fair number of fishes in the open water that swim continually. So things like many sharks, scombrids. Who are scombrids? Yeah. Tuna, mackerel, things like that. Water flow is across the gills because of movement of the body, not the operation of the double pump, but because the animal is swimming. It's swimming with its mouth open. Its mouth is open, the opercular valve is open. So as it moves forward through the water passes into the mouth and across the gills and out the opercular valve. This is a good technique, but it's only good if you swim fast enough. At slow speeds, the amount of energy needed to overcome the increased drag is too great. Why increased drag? Think about it. You have that nice streamlined shape on a fish. Now all of a sudden you're opening up its mouth and you're sticking out the operculum a little bit into the water. That's going to greatly increase the amount of drag on the fish. So we could graph it something like this. If we look at energy versus velocity, the energy required to use our double pump system might go up like this. So the energy required in order to operate our double pump system. As you swim faster, it's going to take more energy to operate it because you're going faster, you need more oxygen, therefore you're breathing harder. But if we look at ram ventilation, it will look something like this. I should have had that should be slanted more. Something like that. So that at your slow speeds, the amount of energy required in order to obtain your oxygen through ram ventilation is greater than the amount of energy that is used when you're operating your double pump system. At the high speeds, I got that right? Yeah, at the high speed, the amount of energy required to use the double pump system is now greater than it is to swim with your mouth open, than to use ram ventilation. So ram ventilation is only going to be used by fishes that are swimming at fairly high speeds. So what would you predict if a scombrid is resting and then it starts swimming? Is it going to immediately start swimming with its mouth open? In other words, immediately start using ram ventilation at a slow speed?
No.
No, it's not going to, because the amount of energy required is greater than the double pump system. So on that same handout is some experimental data. So this was looking at a mackerel, so a scombrid. Swimming speed then is on the x-axis, and the pumping rate, so how frequently that animal is opening and closing its mouth and the operculum is on the left. And you can see at the slow swimming speeds, the pumping rate is continual. Only when you reach a certain speed, which varied with the individual fish, But once you reach a certain speed, what occurs is the pumping rate drops to 0. The point where that pumping rate is dropping to 0 is right there. So when those two lines cross each other, it's now more efficient, energetically efficient, to use ram ventilation than to use the double pump system. So what occurs is that the animal just stops using the double pump and goes totally to ram. Right, so experimental data that's illustrating that. Okay. We should say something about air breathing. We've been talking about fish. Fish mostly get their oxygen from water. But at times, some fish have to supplement the oxygen that they're getting from the water with oxygen from the air. Can you think of any environmental situations in which that might be more likely than others?
Low oxygen content in the water.
Sure. What would give you low oxygen content?
High temperatures.
High temperatures, good. Eutrophic pond, so you have something where you're decaying material and plants and other, they're just using up all of the oxygen. Doubly bad is when it's warm, because as we saw in that one table, as you increase the temperature, there's less oxygen available. So warm areas or warm times of the year could be something that promotes air breathing. So in other words, down at the tropics compared to northern Canada, you might expect to see air breathing a little bit more common. You might expect to see it in the summertime more than you would see it in the wintertime, depending on the fish. Right? Fish can do this in many different ways, and I'm just going to give you some examples. I'm not asking you to remember them, but Electrophorus, which is the electric eel, it has a highly vascularized buccal cavity. So inside the oral area, you have well-vascularized tissues on the sides. And you can get diffusion of air, oxygen from the air, by gulping that air into the mouth. And then it will diffuse into that well-vascularized tissue. Mud skippers. They have highly vascularized area on the interior of the operculum. That would be their accessory respiratory organ. Some fishes use their esophagus or even their intestine. We saw the gas in the swim bladder already. And of course, there are lungs as well. Point is that it's very, very common. Air breathing in fish has been accomplished in many different ways. And one number that I saw, that it occurs in at least 70 different genera of osteichthyes. Right, so it's a widespread phenomenon that fish will get some of their oxygen at some point from the air. And they do so by having vascularized structures, highly vascularized structures, short diffusion distances. But the location of where that vascularized tissue is just varies tremendously. So it has been evolved numerous times in the osteichthyes. So one last thing on air and water and all that sort of stuff. If air is so much better, why do fish die outside of the water? Why do they suffocate outside the water? 300,000 times greater diffusion rate of oxygen. Yeah, they suffocate. They're dying from lack of oxygen.
Because they don't have the water to force it over the gills.
Oh, that's good. There's nothing forcing the material over the gills. That's part of it. For those of you that haven't been a janitor, I don't know, you guys know what a spaghetti mop is? Okay. Think of that mop, and it's sitting down there in the bucket. And all of those strands are just loosely floating in the water. You take that out of the water and hold it up, they all collapse on top of each other. When they're in the water, you've got a large amount of surface area. When you pull it out and hang it up in the air, all that surface area, most of it's disappearing because it collapses on itself. That's what happens to the gill lamellae of the fish. When you take them out of the water, those gill lamellae collapse, and they're losing that surface area. So that's why they're going to suffocate when you take them out. I think I covered everything I needed for the test. All right. So the exam will be on Tuesday?
Monday?
Monday, all right. Yeah, fine. I didn't come in yesterday either. So. And we'll do it right away at 9 o'clock, and then afterwards you can continue on lab or leave or do whatever you want, okay? I do have the Michigan amphibians out. Did everybody get the frog and toad calls? Okay, great. So you can start learning those. I'll bring down a little boom box, and if I can find my CD, and we'll have a little mood music while you guys look at the Michigan amphibians. So there's a list in the course pack, there's a list of Michigan amphibians and jar numbers. Some of them are the same jars as all last time. Okay, all right, I'll
So you said the amphibians are.
We don't have to have a seat.
Still on the 11th.
Nope,
Yes.
not on me now.
Is that a week from today? Yeah, it was January 28th. For some inexplicable reason, I did not put January 28th in the syllabus.
Yeah,
First
or
one.
February 28th?
I think I